Welcome to the review on universal gravitation test, and let's begin. I have the test right here in front of me. Let's start off with a little bit of Newton. What did Newton have to say about the moon and the Earth relationship? What was his great insight? What did he hypothesize about the moon? What was his reasoning about the Earth-Moon relationship? What about the size of the Earth? If it were to increase, the mass of the Earth were going to increase with no change in radius, what would that do to your weight on Earth? What does your weight have to do with? Let's say, for instance, that the radius of the Earth decreases, but there's no change in mass. What would that do to your weight? What about what would be the gravitational attraction between? Would there be no gravitational attraction between two pencils? Or is it only very large? Between two very large objects. Let's see. Let's say I have a force of gravity of 100. Okay. Now, I increase the distance. I increase the distance. I double the distance. I go from, I double the distance between the masses that are being attracted with a force of 100. So I double the masses. What would the new force of gravity be? Let's see. The force of gravity on you is greatest when you are. Where are you standing? On a mountain? Below the Earth, in the center of the Earth? What's your gravity at the center of the Earth? What's your gravity on the highest mountain? Where would you? Where's it greatest? When you're standing far above the Earth's surface, just below the Earth's surface, on the Earth's surface? Where? Let's see. Let's say that a planet has half the mass of the Earth and half the radius. Compared to its weight on Earth, an apple on this planet would weigh what? All right, let's see. What about if you look at Jupiter? It has 300 times the mass of the Earth, yet Jupiter's surface, an object only weighs 3 times as much on Earth. What would the explanation of that be? Wait, that makes no sense. You'd only weigh 3 times more on Jupiter, but it's 300 times bigger. That's a little weird, huh? So you're going to have to be able to understand the equation F equals G times the product of the masses divided by the distance between those masses squared. And if you understand that equation, you're going to be able to do most of this test. You're going to have to know about black holes. You're going to have to know about the two main processes going on in the sun that keeps the sun in existence. Okay? You're going to have to know if you stand on a weight scale in an elevator that is accelerating upwards, why do you observe an increase in your weight? Why wouldn't it be a decrease in your weight? What's one way to determine? One way that astronomers detect planets around distant stars is by observing to see if there is a what relative to the light. Remind me to do the Doppler effect with sound, and the same thing is with lights. Remind me to do the Doppler effect with sound. Okay. How about the How did we discover Neptune? What was it about Uranium's orbit? I'm sorry, Uranus's orbit that led to the discovery of Neptune. Let's see. What else? Force of gravity. What is the Earth? What's the relationship between the Earth and the Sun? What about the difference in between two masses? If I decrease the size of the masses, what do I do with the force of gravity? Does the radius of the mass have anything to do with it? What is the force of gravity dependent upon? And let's see. And that's about it. Black holes, weight versus normal force, and perturbation, Doppler shift. Okay? And that's about it. That was a quick review, huh? Very quick review. Good luck. Have a good day, and goodbye.